Okay, now we're going to, in this lesson, talk about the axis of symmetry and the vertex so that we can graph quadratic functions that have more than just the quadratic term. So we're going to expand out our quadratic functions where we're talking about having the quadratic term, the linear term, and the constant term, and determining where that axis of symmetry is, where the vertex is on the graph, and then we'll be able to graph some great parabolas here. The vertex coordinates, x, y, which I will also be calling at some point in time h and k. But you've got your coordinates x and y that happen to be at the maximum or the minimum of the parabola. That's the vertex. So instead of xy, I'm going to use hk just because xy stands for any point that's on the parabola. I want to talk about the vertex. So we're going to call the vertex hk. This way nobody's confused as to what point I'm talking about. When I talk h and k, I'm definitely talking about the coordinates of the vertex. So h is going to equal the opposite of b over 2a. And at this point you're going, what the heck is the opposite of b over 2a? What's b and what's a? Well, remember from the last lesson, a quadratic function is in the form y equals ax squared plus bx plus c. So here you have your coefficient of your quadratic term. That's your a value. Your coefficient of your linear term, that's your b value. And then your constant term, which we'll use later on, is the parameter c. So the first value of your vertex, h, comes from the opposite of b over 2a. Your corresponding k value is going to be the output when you put negative b over 2a into the function. So I'll show you exactly what that looks like here in this first example. So we want to find the vertex, and the equation for the axis of symmetry given the quadratic function y equals negative 3x squared plus 6x plus 5. The first thing that we're going to do is we're going to identify our parameters. So identify our parameters of a, b, and c from the equation. So a is equal to, I'm going to do my work over here in gray, a is equal to negative 3, b is equal to 6, and c is equal to 5. And I'm getting that from my equation a, b, and c. The coefficient, a is the coefficient of the quadratic term, b is the coefficient of the linear term, and then c is your constant term. It's written at the very end. So we have a equals negative 3, b equals 6, c equals 5. Our second step is to substitute in a and b into our h equals negative b over 2a. So we're going to substitute values for a and b into h equals negative b over 2a. So here's step 1. Step 1. Here's step 2. H equals the opposite of 6, so negative b, the opposite of 6, over 2 times a, which is 2 times negative 3. So that's going to give us negative 6 over negative 6, which is 1. So the first value of our ordered pair hk is a 1. Now we need to find the corresponding output. So that's step 3. Now use your h as an input into your function. And here's the function right there. To find the corresponding output. And that output we call K for our vertex. So here's step 3. Y equals -3 instead of x squared. I'm going to put 1 squared plus 6 instead of x. We're going to put 1 plus 5. So 1 squared is 1. 1 times -3 is -3 plus 6 plus 5. 3 plus 5 is 8. So the value or the location of our vertex is 1, 8. So I'm going to write our answer over here. Our vertex is 1, 8. And the axis of symmetry, we know that this is an equation. X equals the x value of our vertex. And we learned that in our previous lesson. So if you still need help with that, you might want to go back and watch those videos. So let's try again, this time without having to write down all the steps. Now we can just refer to them. So here we go. We've got find the vertex and equation for the axis of symmetry given f of x equals x squared minus 6x plus 9. Our first step is to identify a, b, and c. The coefficient of x squared is 1. The coefficient for -6x is -6. And our constant term at the end is a +9. Step 2, h equals the opposite of b over 2a. The opposite of -6 is +6, so the opposite of -6 is +6 over 2 times a. That's going to give us 6 over 2, which is 3. Our third step, we're going to take that 3. So we now know our vertex is 3 comma something. We're going to take this 3 and we're going to put it into the original function. So f of 3 is equal to x squared minus 6x, right? So in place of x, I'm going to put parentheses, minus 6. In place of x, I'll put parentheses. And then we have plus 9. And then in those parentheses, you put your 3. So 3 squared is 9, minus 18 plus 9. Well, 9 minus 18 plus 9 is 0. So our vertex is at 3, 0. And our axis of symmetry is an equation of a vertical line that goes straight through the vertex. So a vertical line going through 3, 0 is x equals 3. Now sometimes our numbers don't work out as nicely as we want them to. So sometimes we do end up with fractions, and we're okay with fractions. So we're going to give this a try. Our first step is to identify a, b, and c. So a is equal to 4, b is equal to 6, and c is equal to -9. Our second step, h equals the opposite of b over 2a. So the opposite of 6 over 2 times 4. Well, I can say -6 over 8 and then reduce, or I can reduce right now and I get -3 over 4. And that's okay, because sometimes our vertices are not on lattice points. Sometimes they end up being, you know, in the middle of a grid somewhere that isn't a perfect point. So now what we're going to do is we're going to put that -3/4 in and find our output that corresponds. So y equals 4 times x squared plus 6 times x minus 9. We're going to put that negative 3/4 in. And now we're just going to work through the fractions. 4 times negative 3/4 squared is positive 9/16. Minus, because a positive times a negative is going to be a minus. We've got 4 and 6. 2 goes into both of those. So 2 goes into 4 twice, 2 goes into 6 3 times. So we've got minus 9 over 2. And then we have minus 9. So we've got 4 goes into 16 4 times. So we have 9/4 minus 9/2 minus 9 over 1. We need a common denominator. So we're going to multiply by 2. And here we'll multiply by 4. That's going to give us a common denominator of 4. 9 minus 18 minus 36. Here's our minus 18, and here's our minus 36. And that's all over 4. 9 minus 18 is negative 9. Negative 9 minus 36 is negative 45 over 4. If you are struggling with the fractions, not because you can do them and you're just being lazy, but if you are really struggling with the fractions, then we want to make sure that you're not, being sidetracked with fractions and how does this work? So pick up your calculator for now, and we can always go back and perfect our work with fractions, but you can pick up your calculator right now and make sure that you can just get this answer. So if you need your calculator to add 9/4 minus 9/2 minus 9, go ahead and use that calculator. Just make sure that your answer is in fraction form. So with that being said, let's go ahead and try this next example. See if you can come up with the vertex and the axis of symmetry. Then what we're going to do is we're just going to go back and make sure that we know which way these parabolas open, whether or not they open up or down. So go ahead and press pause so that you can work this problem out. Meanwhile, when you're ready to hit play, I'll be giving you the answer. So A equals negative 6, B equals negative 3, C equals 7. H is equal to the opposite of B over 2A, which is negative 1/4. And then when we substitute that in, we have Y equals negative 6 times negative 1/4 squared is 1/16 minus 3 times negative 1/4 plus 7. So I've got negative 3/8. Negative 6 over 16 reduces to negative 3/8. And then I have a positive 3/4 would be the same thing as 6/8 plus 7 over 1. I'm going to get a common denominator there. So I have everything over 8. Negative 3 plus 6 plus 56 is 59 over 8. So our vertex is negative 1/4 for our input, positive 59/8 for our output, and our axis of symmetry is x equals negative 1/4. Now let's just quickly make sure we know which way these open. On the first one, that negative A means that this parabola opens down. And on the next problem, A being positive, see that's a positive A, that means this parabola opens up. And how about the next one? Opens up or down? Correct, you've got it. A is positive, so it opens up. And on the next one, opens up or down? Yep, I heard it. I heard you say opens down, or I heard someone say that. Might not have been you, but definitely someone out there said that, because I heard it. Opens down. So now what we're going to do, now that we can locate where our vertex is and our axis of symmetry, we're going to be able to graph. So in our next video, we're going to do this try. Now this try might be a little bit more, you might be a little bit more comfortable with. So you're going to go ahead and try that one. So in the next video, I'm going to come up with the answer for this one, and then we're going to go straight into graphing.